Good afternoon. Let's do a quick visual and audio check, guys. Make sure, give me a thumbs up if you can see me and you can hear me. All right, very good. Before we get too far into the lecture, let's go ahead and jump over to 6.2 homework. And are there any questions on 6.2 homework? Notice that it started at 22. No clue what was up with that, but are there any questions with that? All right. Hey, so we'll do the same thing. Good question, Christina. So we will do the same thing that we did last time. So all of this will be due for you all. All Chapter 5 stuff will be due. We'll set up the same thing like May 4th. Okay, may the force be with you. So like May 4th, all is due. And you'll have the same options as last time. You can either submit a PDF to me, or you can just simply take it by the school, and then I'll have your next packet. But just like last time as well, we'll have I'll have everything online for you to print as well. So just like last time, probably looking at May 4th though for all that to be due. All right, good questions. Since I'm not seeing any other questions in terms of that homework, let's go ahead and jump to 6.3 notes. Give me a thumbs up if you're ready to move forward with 6.3 notes. Elizabeth's ready. Caitlin's ready. Bernice is ready. Abby is ready. Maddie is ready. Christine is ready. Sorry, I'm kind of slow with it today. I'm trying to get my middle of the day snack, so just bear with me here. Eating is very important. Always got to eat, guys. Do I think this is Christina? I actually just simply I peeled back some, but then I had to take a bite because I don't have all the time in the world to sit here and eat string cheese. So I don't think it shouldn't be long, and it may take us probably an hour to get through all this, but it should be pretty. I'm thinking we should be done by 4 o'clock for sure. So. All right, no worries, Kelsey. Hey, well, good afternoon, everybody. Sorry I was cutting some things and for this lesson today, and looking at trying to get a quick bite in before getting in here. All right, so let's start first with just a simple question. Let's solve these equations. Solve these equations. Okay, so let's solve these equations. 2x equals 4. X plus 2 equals 4. And let's say x squared equals 4. Okay. So to solve this first one, let me minimize me a little bit. To solve the very first one, what we want to do is just simply do the inverse operation of multiplication, which is division. So we divide and get x equals 2. For the second one, we want to subtract 2, which is the inverse operation of addition. And we get x is equal to 2. And then x squared equals 4. We would take the square root of both sides, because the square root and the square are inverse operations, and we get x is equal to plus or minus 2. But what if I gave you this equation? 2 to the x power is equal to 8. 2 to the x power is equal to 8. Now, that's a pretty simple problem. Most of you know the answer to that. Someone type, what is that answer? Type it into the chat box. Three. Yeah, very good, Elizabeth. 2 cubed is 8. We know that. 2 times 2 times 2 is 8. All right. Now, the difference between 2 raised to the x power, let me clean this camera off. The difference in 2 raised to the x power and x squared is that in this part, your variable is the exponent. Here, your exponent is your variable is the base. Here, your variable is the exponent. Here, your variable is the base. Okay? So this is what we call exponentiation. Exponentiation. Okay. So the question is, what is the inverse operation of exponentiation? Would anybody know the inverse operation of exponentiation? And I would assume that no one would know the inverse operation of exponentiation. So we're saying, what's the inverse of this? Okay? And that's because the inverse of exponentiation is what we call a logarithm. Not bad, Christina. A logarithm. It is going to have to do something with a base, though. Okay? So lesson 6.3 is over logarithms. If you have your you're going to need your calculator today. If you don't have that, go ahead and grab that real quick. Okay, so why is it spelled with an I instead of a Y? What is spelled with an I instead of a Y? Logarithm? I didn't know how to teach English to you today, Christina, but logarithm. Probably not the same thing as rhythm. Yeah? Logarithm. All right? So, what the inverse of this looks like is this right here. Log base 2 of 8 is equal to x. Now, this is where a lot of kids start freaking out on me because we're using the word log. The word log is just short for logarithm. What is a logarithm? It's the inverse of an exponentiation. All right? So I've heard horror stories of people, I mean, literally, you can ask kids anywhere. It's like, hey, what is a logarithm in math? And they're just like, I have no clue. You will not be that way. When someone asks you what's a logarithm, it's the inverse of exponentiation. When a variable is an exponent, it is the inverse in order to find out what x is. All right? So log base 2(8) is how that would read. We'd read it just log base 2(8) is equal to x. So then that, and we'll get to a little bit more into that, Maddie, but this right here, x is equal to 3, as Elizabeth said earlier, and that is because 2 raised to the third power is 8. Okay, so let's talk about this whole logarithm. All right, so a logarithm base. So this is a kind of important part. We won't get too much into this today, but there are a few details you know. The b, okay, in the logarithm right here, log b to x is equal to y if and only if b to the y is equal to x. And these are some important stipulations. B cannot be negative. So it has to be greater than 0. So not negative. B cannot be equal to 1. All right, and we'll kind of discuss that here in a second. And x has to be greater than 0. Okay, so the logarithmic base, the base right here is very important. Okay, so this is equal to this if and only if b to the y is equal to x. This base cannot be 0. It cannot be 1. And this x has to be greater than 0. So I've kind of created just a little something for us just to kind of see. So we have log, okay, log base b, all right, log base b of x. I'm going to have to zoom out a lot here, guys. Oh, gosh. Well, that probably will never work again. Here we go. There we go. So log base b of x is equal to y. Okay? So log base b of x is equal to y as long as b raised to the y is equal to x. Okay? So, couple things here. This b here cannot be negative. This b right here can never be negative. And because a negative number raised to a power will not work with this. Okay? B cannot be 1 because 1 to the any 1 basically to the any power will simply be 1. Okay? And the x here it cannot be negative as well. And you'll see more of this a little bit later. All right? So we're basically going to, this is our form, okay? If it gives you b to the y equals x, we're just going to translate that into this right here. B to the x is equal to the y. This is our x. This is our variable right here, the y. Okay? And of course, you can go both ways. All right? So that first problem, we went this way. B raised to the y is equal to x. So that's really just saying log base b of x is equal to y. Okay? All right. So looking back at this, okay, so again, that's just a little bit different visual than this right here. Okay? So the logarithmic function, okay? The logarithmic function, I always forget the A there. Logarithmic function is y equals log base b of x is the inverse of the exponential function y equals b raised to the x. So we have exponential form. Remember, we did this with radicals too. Exponential form looks like this. A to the b equals c. Logarithmic form looks like this. Log base a to the c is equal to b. Just trying to zoom in a little bit from our adventure of zooming out. Okay? it's killing me. It looks like sideways or something. There we go. I like that better. Okay? All right. So, here's what this says. Rewrite each equation in logarithmic form. So, it's in exponential form right now. A to the b power equals c. So, we want to write it in logarithmic form. Okay? So, with number 1, let's write it in logarithmic form. We just write log of the base. Look right here. A becomes your base. Base 17. Your answer over here, C, becomes this right here. The argument is what it's called. 289 is equal to 2. Okay? If I was to write this in logarithmic form, it's just log of base 13 of 169 is equal to 2. Give me a thumbs up if you're good with going from exponential to logarithmic. Give me a thumbs up. I want to make sure you're still here with me. Cool, Elizabeth. Good, Maddie. Good, Bernice. Good, Kristen. Good, Abby. All right. So now let's go. I'm assuming everyone else is good. Good, Caitlin. Good, Kelsey. So now let's go the other way. Let's go from logarithmic to exponential form. And that should be pretty simple. Just 18. 18 becomes your A. This answer over here, your C, is 2. And that's equal to 324. So these are just basically, these are inverses, okay? Same thing over here. 13 squared is equal to 169. Pretty simple. Not sure why there's so much space there. Okay? So that is going from exponential to logarithmic, and then logarithmic to exponential. Okay? So no math is shown there, it's just form. Okay? No math, just simply form. All right, let's jump down to number 5 then. What is log base 4 of 16? Okay? What is log base 4 of 16? So literally, guys, what this is basically saying, well, what is this? Okay? So here's what I want you to think. When you see this, here's what you need to think. 4 to the what power is equal to 16? That is the way you need to think right here. When you see this, log base 4 of 16. 4 to the what power is 16? And what would that be? Two. Very good. So 2. Now, if you have your calculator out, I have lights everywhere. If you have your calculator out, clear out here. Actually, I can turn this light off probably. Oh boy, that killed it. So, if you say on your calculator down here, everybody see above the log button, right to the left of 7 is log. So if you hit log, you get something that looks like this. Okay. That's not necessarily what we have here because we have a base. This log, which you're about to find out here in a second, that has a base of 10. All right, that's called the common logarithm. But what we want is found in math. So you hit math, and then you just scroll down until you see that right there, which is log base. And that's what we want, is log base. And then we just punch our numbers in. So log base 4 of 16. We would find our answer here to be 2. All right? Now, an easy way to get to that log base, just hit math, from the home screen, hit math, alpha, math, and that'll pull it right up, because in math, what goes with it is A, so you just hit alpha, and then the A button is the math button. So again, from the home screen, if you want to get it easy, just hit math, alpha, math, and it'll pull it for you. All right? Going over here to the next one. So log base 2 of 32. So think 2 to the what power is 32? And what would that answer be? Very good, Caitlin. 5. If we were to check that in the calculator, again, shortcut would just be to simply say math alpha math, math alpha math, and we had the log base 2 of 32, and we get our answer to be 5. Okay? So, I need you to understand, okay, this one principle about logarithms, because kids all the time are like, man, what is a log? Like, they taught it to us, but I just don't remember what a log is. A log is the inverse operation of exponentiation. Okay? It's the inverse operation of exponentiation. When you have 2 raised to the x power, taking the logarithm of this, changing it to logarithmic form, can help us understand what x is. Okay? So logarithm it's an operation, just like multiplication, just like subtraction, addition, division, squaring something, square rooting something. Logarithms it's an operation in math. Now, it's a little bit harder to understand the operation behind it. We understand addition. We understand 2 and 2 is 4. But to take the logarithm of something, it's a little bit more complex. But what you need to understand today is that a logarithm is the inverse operation of exponentiation. Okay? I hope that's making a little sense. Give me a thumbs up if you understand what a logarithm is. Give me a thumbs up if you understand what a logarithm is. Cool, Maddie. Good, Christina. Good, Kristen, Elizabeth, Bernice, Abby, Caitlin, Lucy. I about called you Lizzie. All right, so let's go to the second page. If you're not with me, ask me a question. Be happy to answer something. What?
I want another pizza.
I don't have any more. Okay, so shrink me back down. Going at number 7. So 7. What is the log? What is the log base 2 of 8? So really, what we're saying here is the inverse of logarithms is exponentiation. So it's saying 2 to the what power is 8. So that's really, we're saying, what's this right here? You want to say hello to them? You can say hello.
Hi.
Oh, look, you're wearing a green shirt. So it blends in on the back. Alright, here you go. Love you. Alright. So, 2 to the what power is 8? And that should be 3. They said hi, Landon. Two cubed is 8. Sorry. Log 7 of 343. So 7, the inverse operation of logarithms is exponentiation. So 7 to the what power is 343. Three, very good. All right. Now, number 9. 7 to the what power is equal to 1 over 343. A little bit of a tricky one, but I think you guys can handle it. 7 to the what power is 1 over 343? Anybody? Yeah, good, Maddie. Good, Abby. Good, Dom. -3. Keep in mind, guys, 7 to the -3, kick the negative out. Whatever you have left, put it under 1, and that's 1 over 343. Okay? Log base 2 of 1 over 16, 2 to the what power? Will give me 1 over 16. Someone type that into the chat box. 2 to the what power will give me 1 over 16? Hey, good question. Good question on that, Christina. Well, yeah, when you have a fraction, Abby, let me answer Abby's question. When you're using a fraction, yeah, your power is always going to be a negative. If you have some exponentiation problem and you have a fraction, it's always going to be negative because that's the only way it'll get there. Now, talking to you, Christina, we said the x cannot be negative. We said the x had to be greater than 0, right? We're talking about the x right here, okay? So technically speaking here, the x isn't negative. The y is negative. The exponent's negative here. Okay? So look, 1/16 is not negative. All right? So that's fine there. But this is the y. See, b to the y equal x, and x can't be 0. Okay? So oh, dang, I'm sorry. I didn't mean to. I don't know how long I've been silent. So let me re-answer that. So we know that's -4. So to answer your question, Christina, sorry about that. To answer your question, Christina, the x is still positive here. By equals x. Yeah, sorry about that. So by equals x. 1 over 16 is the 1 over 16 is the x, which is positive. But this right here would be the y. like b to the y equals x. So b can't, this will never be negative and this will never be negative, but this right here can be negative. Does that make sense, Christina? And yes, to answer your question, Abby, anytime you have something to a power that's producing some negative, especially if it's 1 over something, most likely that's going to be a negative, yes. And okay, so and then Elizabeth, you said so you could just find the answer for 16 and then put a negative in front of it to make it a fraction. Yes. Yeah. You could say 2 to the what power, or 2 to the 4th power is 16. So then it's negative 4. So again, 2 to the negative 4th. You kick the negative out. Whatever's left, put it under. And that's 1/16. So that's where that kind of math is coming from. Okay? So what if it's not 1 over something? In terms of... Okay. The only way... I guess I can rephrase that. Let me get some math here for you. Okay. So the only way that this is going to produce a true fraction, okay? The only way that this would produce a true fraction is if this number up here is negative. So yeah, I didn't want to commit fully with that, but so if you're looking, look at my calculator here. I got 7 to the, we know 7 to the first, 7 raised to the first power is 7. 7 squared is 49. But even if you start going less than 1, you see 7 to the 1/12 is 1.17. 7 to the 3/4 is 4.3. 7 to the 1/2 is 2.6. So as you see, and then we know 7 to the 0 power is 1. Okay? So then when you start going less than that, that's when you're going to see that negative come in. So that's where we get 7 to the 1 power is 1 over 7. And obviously 1 divided by 7 is the same thing there. Okay? So in order for it to be a true fraction, not a, man, I can't even think of the word. Not an improper fraction, but a fraction where the numerator is smaller than the denominator, that will, in order for this to happen, that has to be, in order for this to happen, that would have to be negative. So you said, what if it was like 2 over 16? Well, 2 over 16 would simplify to 1/8. So like 2 over 16. So if it was like log base 2, 2 over 16, then that would be log 2 of 1/8. Right? And then that'd be 2 to the what power is 1/8. And that would be negative 3. Not sure if that's answering your question, but it will always, if it's a fraction, that's going to be negative right there. Okay? So if it's a fraction on the right side, this will be negative. If it was something else, like log, and that's the thing. I mean, it's kind of hard to 7 raised to the So let's just say like log of 2 to the 3/7. So if the numerator is not 1, I think is what everyone's trying to interpret to me. So so we would say here log 2 of that would be 2 to the what power is 3/7. And for me, I don't know off the top of my head, so let's just look at that on the calculator and see, just hit math alpha of that and just say log 2 of 3/7. And there again so it's always going to be negative. If it's a fraction there, it's always going to be negative, even if it's not 1. Does that clear that up? I've never answered that question before, so I wasn't committed to just say, yeah, all negative, or it's always going to be negative. But obviously here, no matter what fraction you put in there, it's going to produce a negative number. Good question, though. Very good question. Took me a minute. Sorry. Okay. So, I think that's a really good question. Just to say, anytime you have an exponent, something raised to an exponent, and you have a fraction, that's going to make that negative. Okay. It may not be a nice smooth number like -3 or -4, but like that last one was like -1.22. So if you have something raised to a power and it's equal to a fraction, it will be a negative exponent. Very good question, Elizabeth. All right, so continue right along. Looking more into this whole logarithm thing. All right, so the base 10, sorry, I'll write a few notes here. The base 10 logarithm is called the common logarithm. Is called the common logarithm. And is written as log x with the base of 10 implied. Okay? So the base 10 logarithm is called the common logarithm and is written as log x with the base 10 implied. Okay? So a lot of the logarithms you're going to see, and that's why they call it common logarithm, it's going to have a base of 10. All right? So if you were to see something like this, log of x, that is simply this, guys, log base 10 of x. Those two are the same thing. Okay? All right. So, on my calculator, just to show that, because I think it's important for us to see that, if we say, if you have your calculator, grab it, to the left of 7 is log. So let's just say, let's find log of, I don't know, 100. And that is 2. Okay? Now that should make a little sense to you because 10 squared is 100. But if I hit math alpha math, I get this. And if I put a 10 as the base and I type in 100, I get the same answer too. And the point of that is this right here. Is that log x, log of something, is the same thing as saying log 10 of something. Okay. So, one more little note. The base E, y'all remember E from the last lesson, 2.7? Who knows the rest of it? Somebody type that in. 2.7. Anybody remember what it was? Like those first 10 or so digits? $2.7. Anybody? Oh my gosh. 2.718281828 4590 45. Come on now. Get that down. So the base E, there we go. So the base E logarithm is called the natural logarithm. And is written as ln of x. So these are the two most common logarithms you're going to see. You're going to see the common logarithm, which is just log x, and then you're going to see the natural logarithm, which is ln of x. Okay? And then this, ln of x, is equal to the same thing as ln of e raised to the x power. Okay? So, notice here, this is log, all right? Log, and look, it kind of helps you here, guys. Log is with the blue button of log is 10 raised to the x power. Natural logarithm is e raised to the x power. So log, okay, keep log in mind, that's 10. And of course, this is a different button. That's 10 to a power, and that's e to a power, which is basically the inverse of these two. And notice, and you'll kind of see that within the calculator. Notice the inverse of x squared is the square root. Okay? A lot of the times you'll kind of see that on there. So all three of these right here are inverses. X squared, it's blue. The blue button is the square root, which is its inverse. Log, which is base 10, it has a log base 10 of something. The inverse is 10 to the x, and same thing here, e to the x. So when you're doing this is called the natural log. You can say ln of x, but it just simply means the natural log, and that natural log just simply means that its base is e. Okay. Now these ones we worked up here, they weren't common logs or even natural logs. They were just simply a log of base of 7 or a base of 2, whatever it may be. So to get the point in the calculator, let's just say the ln of 100. Okay? ln of 100 is 4.605, 170186. Okay? So, with that, now they don't have like they they don't have a ln sub base and then of something, but we can simply say math alpha math and just get a log base, but make our base e, which is the division sign, second the division sign, and then say of 100, okay? Because that's us saying that ln of 100 and the log of base e to the 100th, we're showing it's the same thing, okay? But just know, log is always the base of 10. Anytime you see log of something, or if you see log of something, it's just simply log base 10. If you see natural log or ln, that is just simply, it has a base of e. Abby, you said, how do you do the log e? Oh, so, and the reason I did the log e, you just hit math alpha math. And that takes us to a log base, and we can just type in second, and then it's the division sign right here is where e is. The division sign is e, and then that's where I came with 100. Does that make sense? Okay, Christina, the ln is right below log. The ln is right below log. So I just hit ln. I'm kind of too zoomed in to do this, but I just hit ln and I get log. The ln button is right here. So I just hit ln and and it's the button, as Maddie said. Cool. All right. So now let's go to solving equations with this type stuff. Okay? So it says solve. It says 10 to the nth power is equal to 68.3. This is an exponentiation equation problem. So just like if you had 2x equals 4, you divide by 4. Here we're going to take the logarithm. All right? Now, you do actually have two options here, and that's what makes logarithms kind of unique, is you do have two options. So I'm going to work on both ways, okay, so you can see, and you can kind of make a decision, oh, I like that way better than this way. So my first way is converting it from exponential form to logarithm form. So logarithm form would look like this right here. Log, remember what we did in the beginning? Log base 10 of 68.3 is equal to n. This is like the first way, okay? Now, with these equations, there's no way you're going to come up with this number off the top of your head. So no one knows 10. We can ask ourselves 10 to the what power is equal to 68.3, but that's where your calculator is going to come in handy. So once you're here, again, can someone tell me the button combination to get to a log base? Someone tell me the button combination. Type it into the chat box to get to that log base where we can type a base in. Yeah, good. Math, alpha, math. That gives me my log base of 10. And then I just type in 68.3. Very good, guys. Very good. I hit enter, and I get n is equal to 1.8344. And we'll go 4 decimal places. Somebody answer that. What place value is 4 decimal places? We'll do this on the homework as well. What place value is that? Yeah, very good. 10 thousandths. All right. Now, going back to our calculator, guys, keep in mind what we just said. What we simply just said was that, moving up here just a little bit, that log base 10 x is the same thing as log x. So what you could do, instead of just typing that in, just come down here and hit your log button to the left of 7, and you get the log here, and you just got to say 68.3. And again, that's going to give us the same answer because log and log base 10 are the same. So my answer to the nearest 10 thousandths is 1.8344. So long ago when your elementary teacher told you need to know your place values because one day a math teacher is going to tell you need to know to this point, here we are, guys. I want you to round these to the nearest 10 thousandths. Don't ask me why, because then I'll make you go to the 100 thousandths. All right. So now that's the kind of the first way. Your second way, if you add 10n equals 68.3. Yes, Abby. Always go to the 10 thousandths on the. I'm going to do it on the notes. You do the same thing on the test. Okay. So who can tell me what else I could do here instead of converting it from exponentiation to logarithmic or exponential to logarithmic? What else could I do? What's the inverse of exponentiation? What's the inverse of this? We'll get to one like that, Abby. We'll get to one like that. Anybody know of another way I could do this? Okay, so let me rephrase what I'm saying. Yeah, okay, yeah, okay, good, Elizabeth. No, you're right, Elizabeth. So we did just take, here's what we did, and this is why this is so important for you guys to see. So 10n equals 68.3, and what Elizabeth is saying is, hey, I just thought we took the logarithm, which we did, but this is just a, no, not a natural log yet, Christina, calm down. So, but what we did with this first problem was we converted it to log form. So we went straight from exponential to log form, and then we calculate it. But the second way you can do it is just to take the log from the start. Okay? I got blurry all of a sudden. All right. So what I could do from the beginning is just write it like this. Log of 10 to the nth power, log of 68.3. That's just like dividing by 2 on both sides. If I take the log of this, what I do to one side, I have to do to the other. Okay? Now, the log of 10, all right, think about what log 10 is. Log 10 is just log base 10 of 10, and that would just be simply 1. Okay? So, if I say what's the log of 10, That's 1. Again, because think about what that is, guys. That is just simply log base 10 to the 10. So 10 to the what power will give me 10? 1. Okay? So if I just take the log of this side, and laws of equation say what you do to one side, you got to do to the other. So I have to take the log of that side. Well, log base 10 of 10 to that nth power simply just, that cancels on that side. Log of 10 is just 1, so it cancels, leaving me just n, and then log of 68.3 is equal to what we discovered a while ago, 1.8344. 1.8344. So same answer, okay? But the difference, and you may be saying, well, I don't really see a big difference there, Mr. Ipock. You're just, yeah, there's not that big of a difference, but it's just the way, this way we convert it to log form and get the answer by typing this in, or we just take the log of both sides. You're doing the same thing naturally, right? But that's just converting it to log form opposed to just taking the log from both at the start. All right, let's move on to number 12. I'm going to do it both ways again. So here we go. Number 12, let's do it the first way. That would be log base 10, right, of 83 equals k. And we know that that is really just log of 83 equals k. When I type log of 83 into my calculator, log of 83, I get 1.9191. Okay? So that 7 is going to round that 0 up to a 1. So 9191. So k is equal to 1.9191. I want you to have your calculator out, so we're going through this together. You need your calculator out because I'm gonna let you have a little bit of freedom with the calculator. Now, if I do it the other way, 10k equals 83. I just say log. That cancels. K is equal to log of 83, which we just found to be 1.9191. All right, tell me which way you like. Do you like number 1 way or number 2? Do you like converting it, or do you like just taking the log from the beginning? Just type it in which one you are. I want to make this is a kind of a way to check in with you, make sure you're still there with me. Sebastian, when you say the second part, do you mean like the number 2? That is so funny. Caitlin's 1, Maddie's 1, Christina's 1, Kelsey is 2. The rebel Kelsey, number 2. Bernice is 1, Abby is 1. Now, I would have known most of you would have went with number 1, and I probably could have picked out that Kelsey would have went with 2. Kelsey, you see things differently, so I'm liking it. I like 2 better myself just because it's just kind of like when you got 2x equals 4, you think, oh, just divide both sides by 2. Kind of same there. You're not necessarily changing the form or do anything like that. So I prefer number 2, but I'm cool with you guys. You guys know I'm not a hater. So Sebastian, the second way looks like, or sorry, let me rewrite up here. 10k, 10 to the k power is equal to 83. So Sebastian, basically what this is right here, okay, is it's exponentiation. All right, it's an exponent that is a variable. All right, so as we've learned today, the inverse of exponentiation is logarithms. Okay? So you can, and since this is 10 here, notice they're all 10 because that's a very common log. All right? This is 10 here. What we can simply say is just say the log. Okay? Now, we can say log here because log has a base of 10. All right? If this was not 10, we could say the log, but our base would have to be the same of whatever that was. So if it was 7, we'd have to say log 7, and then log base 7 on this side. But since it's just 10, I don't have to write log base 10. Log base 10, I can just write log. And log 10, as I showed you on the calculator earlier, log of 10 is just simply 1. So, and that's because it kind of cancels out. So this cancels basically here, leaving me nothing but k on this side. And then what I do to one side, I have to do to the other. So I say log of 83 on this side as well. And that's where I'm getting k is equal to 1.9191. Does that make sense, Sebastian? Yeah, exactly, Christina. It's just the known. It's implied. So, and that's what I try to say up here was that log x with the base 10 is just basically, it's implied that it's 10. Same way with the square root, that normally a radical, we would actually call, and when you get to college, if you go into math, that's where like professors, they'll get really like specific. So we wouldn't call that a square root. We call it a radical. We call that a square root. Okay, but it's universally known that this radical is a square root. Or to get real more specific, they would say a radical with an index of 2. All right, cool, very good. Moving on to 13. So 13, 6 times 10 raised to the r power is equal to 45.9. So guys, the main goal of equations is to isolate the variable. So again, we want to isolate r. We want to see what r is here. So in order to isolate that, I probably need to clear everything else away from it. So what else do I need to clear from that? What should I do first here? Yeah, good, Caitlin. Divide by 6. Okay. That cancels there, leaving me 10r is equal to 45.9 divided by 6 is equal to 7.65. Okay? Now, first way would be this. Log of 7.65 is equal to r. Now, when I don't write a base down here, that base is 10. It's implied. I don't have to write anything else. So, in actuality, we're doing this kind of the same thing as the second way. It's just, your format is just a little bit different. It's practically this. I mean, it is the same thing, but just the way you go about it can look a little bit different. So then we just put in our calculator log of 7.65. And we get 0.8837 when we round to the nearest 10 thousandths. R is equal to 0.8837. All right, moving right along. 14, negative 2 times 10 raised to the nth power is equal to negative 16. So divide both sides by negative 2 first. We're trying to isolate that variable. 10 raised to the nth power is equal to positive 8. So again, the inverse of this is just taking the log. So log of 8 is equal to n. And then I say log of 8 is equal to 0.9031. Because this 8 right here bumps that 0 up to a 1. Okay? All right, let's keep rolling. 15. 8 times 10 raised to the 2p is equal to 97. Okay? 8 times 10 raised to the 2p is equal to 97. So, first step, divide by 8. Okay, 97 divided by 8 is 12. 10 to the 2p is equal to 12.125 when we divide both sides by 8. Okay? Then from here, we just take the log of both. I say take the log of both sides, but really, you all like the other form. Let's change it to logarithmic form. So logarithmic form would just simply be log, and that, to be honest, it probably is better so you don't get too confused. Log, we know it's base 10 of 12.125 is equal to 2p. Okay? So, this one I'm going to probably give you a little bit more freedom than you've gotten from me with your calculator. Okay? So let's say log of 12.125 is equal to that right there. Now, because I have you rounding to the nearest 10,000ths, because I have you rounding that much, you need to keep that decimal where it is in order for you to get, and the reason why I'm having you do the 10,000 is because that's what your answer key will be, so I don't want you to get confused on what is what. So you need to keep this 1.036811747. You need to keep it in that. But I'm going to give you a little bit of freedom here. You don't have to write it down, all right? So basically, I'm going to write it down this first problem just so you kind of make sure you understand what I'm doing, okay? So I'm going to write that down real quick. So that's actually sorry about the shaking, 1.083681747 equals 2p, okay? Now again, I'm writing it down this first time just so you see what's happening. Then from there, I just need to divide both sides by 2, guys. So then with my calculator, I can just say divide, and it automatically hits the answer divided by 2. And I get this right here, so P is equal to 0.5418. And I will explain what you can do on the other problems instead of writing it down. I'll explain those in the next couple problems. Okay, jumping over to this one. Well, notice that 8 and 97 is the same, so that's 10 to the negative 9p is equal to 12.125. So same thing there. All right. Then from there, we just change it into logarithmic form. So log of 12.125 is equal to negative 9p. Okay. So again, with my calculator here, if I was to work this out, okay, I'm going to say log of 12.125. I know we already have the answer, but that's that, okay? But now from there, what I'm fine with you doing is just saying divided by negative 9 and then getting your final answer there, okay? So P is then equal to negative 0.1204. Give me a thumbs up if all this is kind of making sense, guys. Good, Bernice. Good, Kelsey. Good, Abby. Good, Kristen. Good, Elizabeth, Maddie, Christina. Okay. All right, let's keep moving on. 17, 6 times 10 raised to the 10a plus 10 minus 8 equals 14. So we know we need to add 8 and then divide by 2. So that's 6 times 10, 10a plus 10 is equal to, what would that be, 22? Okay. 22 divided by 6 is, that would be 10 to the 10a plus 10 is equal to 3.6 repeating. Okay, so then from there, let's log. So log of 3.6 repeating. Hey, good question, Elizabeth. We don't combine 6 and negative 8 because 6 is being multiplied by this. So we would add 8 first and then divide by 6 on both sides. Does that make sense, Elizabeth? Okay, cool. Very good. Very good, Elizabeth. So, hey, it's so good to see you in class today, Elizabeth. I'll give you a hand clap. Let me throw some, I think that means hand clap. That may mean to wash your hands. So everybody give, I'm not sure what I just sent. I thought that was hand clap, but it may be wash your hands. Oh, you probably need to be washing your hands, or everybody needs to wash their hands. But everybody give Elizabeth a hand for being here with us today. Thank you so much for being with us today, Miss Elizabeth Woods. All right, continuing on. I gotta hurry because I told Abby 4 o'clock, and she's gonna be tripping if I don't get her out of here by 4 o'clock. So, thank you. Yeah, there we go. There's the hand claps. There's the praise. Yeah, very good, very good, very good. So, Abby's acting like she got somewhere to go. And Abby, we know you ain't going nowhere because if you are, we will straight up report you. All right? So, all right. Going to this. Oh, no, we're not done over here. Log of 3.6 repeating is equal to 10a plus 10. I'm sorry, I lost our conversation, Abby. The delay in me getting your messages, it's just kind of, I lose the conversation. Hey, there you go. Got places to walk, wait to lose. Hey, go do your thing, girl. All right, so from there, this is where we're going to do a lot of math on the calculator, okay? You guys have been crying about how I don't let you use calculators. This is where I'm going to let you start using it, okay? So let's find log of 3.6 repeating. So I'm just going to put in a bunch of sixes. That should get the job done, okay? 3.6. And I get 0.56 427143204. So we don't need Zoom, Christina. Calm down. Quit making just Willy Wonka ideas. Quit throwing them out there. Okay. So from there, we know that number would go right here. Okay. So instead of making you write that big long number out, now if you want to, go ahead. But we know we're going to have to subtract 10 from that number and then divide whatever that is by 10. Okay, so I'm going to subtract 10. That's doing the inverse of that. So technically my next line would be negative 9.4357. Okay, then I divide that number by 10 and I get this right here. 0.94357, which would be 0.9436. So A is equal to 0.9 or negative, make sure it's negative 0.9436. Now, you won't probably ever hear me say, let's skip some steps here with the calculator, okay? But with this, you got to use it for that log anyway, because not too many of us know what 10 raised to what power is 3.6 repeating. That's pretty challenging, okay? All right. Moving right along. No, we Zoom tomorrow. Yeah, that's correct. Why are you calling me the devil, Abby? Are we Zooming Friday? No, we're not Zooming Friday. Look at the schedule. We Zoom tomorrow at 6:30. Okay? Tomorrow at 6:30. All right. So jump over here. We know we got to subtract 5 from both sides. That's 6 times 10 to the 10 minus 2a equals 22. Divide both sides by 6, and I get 10 to the 10 minus 2a is equal to 22 divided by 6 is 3.6 repeating, as we just found out. Okay? And then from here, we just need to say log of 3.66 repeating. Now, we know there's a base 10 there, but with log, it's implied, is equal to 10 minus 2a. So this is where I'm cool with the calculator coming in. And here's how we would work that. The log of 3.66666666666 is equal to that. But then we know that would replace that right there. And I'd still have to subtract 10 and divide by negative 2. So if I subtract 10, get that. And then if I divide by negative 2, I get that right there, 4.7179. A is equal to 4.7179. I'm all up on the arm. Okay? All right, give me a thumbs up if you're good with common logarithms. I did, Maddie. It is on your, it should be in your email. Should be in your email from the email I sent. That would have been on Sunday. Is that correct? Can someone confirm that you all did receive that Zoom link and information? Okay. So, solve each equation, round your answer to the nearest 10,000. All right, so here we go. E to the R is equal to 6. Okay, E to the R is equal to 6. Okay, cool. Very good. Thank you. So E to the R is equal to 6. So what are we going to do here? Okay. So this should be very simple in the fact that we're going to work these just like we did the last one. But we're not using log now. Log has a base of 10. But what has a base of e? What kind of logarithm? That would be a natural logarithm, or ln. Okay? So what we do here is we simply say ln, and that ln just simply means log of a base of e. That means the same thing. Okay? So a natural log, and we're just going to say of 6 is equal to r. Okay? So our calculator here, I just type in the natural log of 6, and I get 1.7916. No, I'm sorry. 1.7918. You round that 7 up to an 8. Okay? So R is equal to 1.7918. Jumping over there to the next one. So this, we change it to logarithmic, or we change it, to logarithmic form. Now, logarithmic form, it looks like this, guys. It would look like log e to the 78 is equal to x. That's the standard logarithmic form. But we know that this right here just simply becomes ln of 78 equals x. Are you all following me in that? Give me a thumbs up. That's important that you see this, okay? That ln is just simply it has the base is e of the log. It's no longer 10, it's a base of e. Give me a thumbs up that we're cool there. All right, cool, Kelsey, very good. And then the logarithm of 78 is equal to, cool, thanks guys. So x is then equal to 4.3567. All right, just a few more left. So what we should do here first, 9e to the r equals 17. Divide both sides by 9 first. We get e to the r is equal to 17 over 9 is 1.8 repeating. So we just say the natural log of 1.8 repeating is equal to r. So then I say natural log. Now look, it doesn't automatically put this in as my answer, but if you have this type of calculator, you can just hit up and it'll click on that. It's like your history, it'll highlight it blue, and you just hit enter and it'll type it in for you. Okay? Another way to do that is if you hit LN, obviously your answer's not there, but if you go in, if it's your last answer, you can hit second, and then hit the negative sign. Now that's going to give me, that will give me that right there, okay? And that's not what I want. But if that was your last answer, you can just do second and negative sign, and that'll put that in there, okay? So that would be 6.3. Okay, now this is, here comes your example, Abby. So this would just simply be R is equal to 6, or excuse me, R is equal to 0.63. And because it's 5/9, that would round that up to 6, okay, and 0. But we wouldn't necessarily have to put the 0 on the end, so we could just say R is equal to 0.636. And that's rounding it to the nearest 10,000. Does that make sense, Abby? if Abby is even still with us. Oh, okay, cool. All right. Go to the next one. Divide both sides by -6. I get e to the p power is equal to 74.5 divided by 6 is 12.416 repeating. The 6 is just repeating. So then, guys, you guys know I can do the natural logarithm of 12.416 repeating is equal to p. So I take that over here, and I say natural log of 12.416. Put a bunch of 6's in there just to make sure you're getting the correct answer. And that would be 2.5190, okay? So just so P is equal to 2.519. You wouldn't have to put the 0 on there since you're rounded to the nearest 10,000s and the ending is a 0. Moving right along, add 1 here. That's e to the negative 1.4n is equal to 16. That would be the natural log of 16 is equal to negative 1.4n. So, natural log of the natural log of 16 is equal to 2.772588722. Now, this is where we're going to have to do a little bit of work on the calculator before. But something else I want to point out to you all. You do understand. I want you to understand the way logarithms work. So, what is this number actually right here? Okay, this number 2.772588722 is what power. Okay, is the power is e raised to this power will give you 16. So watch this. E raised to the 2.772588722. Now this has nothing to do with this problem, but again, I want you to understand logarithms, okay? So natural logarithm has a base of e. So we're saying e to the 2.772588722 is equal to 16, okay? I'm just wanting you to kind of understand that, all right? So going back to the problem that we had before, okay? Going back to this, just wanting to kind of make sure we're seeing the flow of that. So we were right here. We just found the natural log of 16. So now we know that number would go here, 2.77258. But let's just divide it by negative 1.4 instead of writing it down. And we get negative 1.9804. N is equal to negative 1.9804. Jumping over here to this next one, e to the n plus 6 is equal to add 125. That's the natural logarithm of 25 is equal to n plus 6. So the natural logarithm of 25 is equal to 3 point whatever that is. And then we just need to subtract 6 from that number. And get negative n is equal to negative 2.7811. Yeah, 2.7811. All right, moving right along. We got to add 4 here. That's 7e to the negative 6v minus 5 is equal to 48. 48 divided by 7 is a very big number. So, sorry, I didn't mean to do that. So I'm going to say here e to the negative 6v minus 5 equals 48 over 7. I'll just keep it as a fraction. And then I'm going to do the logarithm. So the logarithm of 48 over 7 is equal to negative 6v minus 5. So I could keep it as a fraction so I don't have to write that big number down, but it's totally up to you. So I know that 48 divided by 7 is this number, so I can type it in using that, or I could type it in saying 48 divided by 7. So natural logarithm, I'm just going to use that, is equal to that right there, 1.925, and then I'm going to have to add 5 to that, right? Because this number, 1.92, would replace this, and negative 6v minus 5, add 5 to it, then divide by 6. So add 5 to it, takes us to that, and then we divide by negative 6 to take us to our actual answer of, what do we got here? V is equal to negative 1.1542. Okay, last one of the day, guys. Sorry to keep you for so long today. 7e to the 6.9 minus 3v is equal to 93. That's e to the 6.9 minus 3v equals 93 over 7, which I'm assuming is a very good sized number. Yes. So then I say the natural log of 93 over 7 is equal to 6.9 minus 3v. From there, the natural log of 93 divided by 7, natural log would take me like 2.5 something. I'm then going to subtract. So 93 divided by 7 was 13 point something. I do the natural logarithm of that number. I get 2.5. I'm then going to subtract 6.9 from it, minus 6.9, because the inverse, and then divide by negative 3. And I get v is equal to 1.43, and it's 7.7, so it'd be 7.8. Questions on natural logs or logarithms? Any questions at all from you guys? Cool. What do y'all think about this? What do y'all think about logarithms? Just couple word response, or this is dumb, this is hard, this is pretty easy. I like it. What do you all think? Not a problem, Abby. Pretty good? Okay, cool. Go. All right. Here's the thing I need you to know, though. Leave knowing this right here, okay? Leave knowing this. A logarithm is the inverse of exponentiation. So anytime you have a exponent that is a variable, know that's exponentiation. And in order to solve for that variable exponent, you would have to take the logarithm. Okay? Know that today, so know that you're not, I don't want you to leave saying I don't have a clue what a log is. I used to have this one kid always come to me, he'd be like, what's a log? What's a log? What's a log? So, is a log found in the woods? A log is the inverse of exponentiation. If you guys don't have any questions, thank you so much for your attention. Plan to see you guys tomorrow in the Zoom. I think yours starts at, Bernice said 6:30, okay? I'll see you there at 6:30. It's not mandatory. We can do a Q&A. I can ask you guys questions. We can discuss stuff. We can talk about the MJ documentary. We can talk about whatever you guys would like to talk about, politics, maybe something. We can keep it simple. We can go long, whatever you guys would like to do. Just let me know, or I'll just see you there tomorrow. Thanks so much, guys. Have a good day. You're dismissed. Thank you, Maddie. You have a good day as well. Good day, Elizabeth. Good day, Christina. See you, Bernice. Have a good day. If you have any questions, ask me.